coming at ya. What's up, everybody? Happy Friday. Let's talk about multiplying polynomials. Your favorite, my favorite, multiplying polynomials. Boom. So we talked about adding and subtracting yesterday, and they were like old hat, right? We already knew how to do that, kind of. Multiplying is not the same. Let's start monomial with a trinomial. So let's say we add 2x squared times negative 4x squared minus 8x plus 7. Now really, when you think about multiplying with polynomials, you always want to think of it as distributive property. Really what's going to happen, no matter how many terms are on this side, we're going to distribute those terms to everything in the second polynomial. So, when I do here, 2x squared times negative 4x squared, you actually know how to do that because we just went through exponential rules, and these numbers have the same base, so we add their exponents, that's going to be x to the 4th. Numbers out in front, we just multiply them because that's what the problem says. 2 times negative 4 is negative 8. You guys already know I'm going to say this, but I like to bam add the opposite throughout all those, so it's always a plus sign. That always helps me. 2x squared times negative 8x. Well, now we have 3 x's, 2 here, 1 here. So that's going to be x to the 3rd. Negative 8 times 2 is negative 16. And then the last term, 2x squared times 7, is just going to get you 14x squared. So as you can see with a monomial, that's pretty easy. We're just distributing this number times all the stuff on the inside. When we have those exponents, even if they're crazy exponents, we know we're just adding numbers if they have the same base, right? If they don't have the same base, we just kind of tack it on. So for example, if I did something like 9xy cubed times 3xz squared, right? We do the 9 times 3. The x's are both 1s, so we can add those, get x squared. The y doesn't go with anything, we just tack it on. The z doesn't go with anything, we just tack it on. That's kind of how the rule works, right? So, there we go. All right, now let's do the most common that you will see, and that is a binomial with a binomial. So let's say we do 4x minus 6 and 5x plus 2. Now, just like when we did it with a monomial, what I tend to do is when I distribute, I go one at a time. I take turns is what I call it. So I'm going to distribute this 4x to everything on that side. So kind of look at just the piece, right? 4x times 5x is 20x squared. 4x times 2 is 8x. And then I'm going to go ahead and take turns with the second one because I went to everything on that side. So negative 6 times 5x is negative 30x. And lastly, negative 6 times 2 is negative 12. So as you can see, every single term had a turn when they multiplied. So I went here, distributed to everything. I went here, distributed to everything. But now what we need to look at is, are there any like terms when I get done there? So notice that my middle here, 8x and negative 30x, we can simplify that. So when you multiply, once you multiply, then you have to go through and add any kind of like terms that you have. So 20x squared, that doesn't match with anything. 8x plus negative 30x is going to be negative 22x. And then, of course, negative 12 doesn't match with anything either. So when I multiply a binomial by a binomial, I am going to get a trinomial. Pretty crazy, right? So that's kind of the gist of any binomial times a binomial. Now, the common mistake that you guys are going to see, people think, let me erase these lines so that you can kind of see it normally, right? People tend to think you just do the first terms and then the last terms, and they miss this whole middle part. That's really important. You have to do every number on the left side, every number in that polynomial, times every number in the other side's polynomial. And then add your like terms. Now let's go one step further today. Let's go a binomial and a trinomial. And let's kind of get a little crazy here just in case you see something like this. So let's go, let's go 9x minus 4y. And then let's go 2x squared plus 13x minus 2y. Okay? This one is, it's not too bad, but it's not going to be your favorite thing in the whole world, probably. So, take turns. We're going to do the 9x first. So 9x times 2x squared, we're going to get 18. And then we'd have 3 x's, so x cubed. Not so bad. 9x times 13x, we have 2 x's. 9 times 13, 90, and 27 is 117. X squared. And then 9x times negative 2y, that's where it gets a little weird. It's going to be negative 18xy. Right? X times y, neither one of them add up. We just put them xy. And that's only half of our problem, because now we got to distribute this negative 4y. So negative 4y times 2x squared, this is where it's going to get messy. We would have negative 8x squared y. Now this is just a suggestion to you, but when I have mixed variables like that, I always try to go alphabetical order when I write them down, because it's going to be easier to match them up when you add like terms, right? Because x squared y is the same thing as yx squared, right? Commutative property. It doesn't matter which order you write those. So I always try to write them in the order, x's first, y's second, z's last, that kind of stuff. All right, negative 4y times 13x is going to give you negative 52 xy. And then negative 4y times negative 2y, I'll have to go down the side here, forgive me, is going to be 8y squared, because y times y. Now, this is where it gets a little easy to make mistakes if you're not sure about which ones are like terms, right? So just be really careful there. I just kind of always go one at a time. So x cubes, I don't have any other x cubes. Do I have any other x squareds? That's x squared y, and not quite the same thing. I do have negative 18xy and negative 52xy. So I can add those together. 67, negative 70xy. I don't have another x squared y, and I don't have another y squared. So in this case, I kind of made it that way, but it's going to turn out that we only have one set of like terms. You might have a bunch, right? Especially if you did a trinomial and a trinomial, there's going to be a lot of terms. So you might have a lot of like terms here. You got to be really careful when you're adding them together. And then the last thing we're going to do is make sure that we write that in standard form when we're done. So it looks like 3 is the biggest degree. Here's a degree 3. That's it. So we're going to go 18x cubed. You can put little x's through them after you write them. I kind of like that. We have negative 8 x squared y. And then we're down to degree 2, so we'll go 117 x squared. And then we'll go negative 70 xy. And lastly, 8y squared. And we're not going to be able to simplify that any farther than that as we multiply. We can't add any more like terms. So, the idea of multiplication, it's not bad. You just got to do a lot of distributive property. And then make sure you combine all those like terms at the end. And that's multiplying polynomials. You guys have an excellent weekend.